just a minor correction, I'm not the lead SE for WSB, but I am for a particular area, which is intelligent transportation. As you know, engineering is a vast area. System engineering has practiced in different streams. So I was invited to speak on this topic by Transport Working Group coordination for this event, which I'm very grateful. And I know this is a topic of interest, so I reached out to my current client, Miranda, very smart lady, and director of the Queensland Transport for Main Roads, Queensland Department of Transport Main Roads, program director for the Cooperative and Automated Vehicle Initiative. Unfortunately, she can't make it today. So, as Bill mentioned, Stuart Allen Keeling will be here to talk on her behalf. And what I want to very quickly identify is, I guess, Miranda's presentation today, which Stuart will kindly present, is really about the government's role in this domain and what Queensland Transport is trying to achieve, and the Queensland Cabinet program itself. And then I'll follow through to talk about what that really means from a systems engineering perspective, what the challenges are to the systems engineering community really, where we can help to contribute to what's going on in the world, in our local domains or local owned projects, what the impacts are, where things are at in terms of exploration in different jurisdictions, just a very quick generic overview. And as I said, finish off with a bit of a AC lens and identify what really the challenge should be within the systems engineering transportation community to where we can, contribute. So without further ado, Stuart, if you can come in to talk about yours. Yep.
Hi, I'm Stuart. I'm not an engineer. I'm an IT person. I'm the security lead for the Cooperative and Automated Vehicle Initiative for Transport and Main Roads Queensland. I'm filling in for Miranda, and I'm fantastic at public speaking. Not. So we'll see how we go. So Transport and Main Roads has some, what do you call these prints? That's not right. What's down there? Isn't there a play button? Transport Main Roads has 5 principles. They're the principles of the Queensland Government, obviously. Customers first, unleash potential, be courageous, ideas into action, and empower people. That's our strategy. Integrity and accountability at the top, creating jobs and a diverse economy, protecting the environment, delivering quality frontline services, building safe, caring and connected communities. So these are just the slides that normally accompany all of Queensland Government's presentations. That's Transport and Main Roads Strategic Plan. Now, we fit very nicely under innovation in that plan. So our vision for Transport and Main Roads is creating a single integrated transport network accessible to everyone. A little bit of information about our organisation. Some highlights there would be, in fact it's not there, but we conduct 3.3 million face-to-face transactions annually. We have 3.6 million drivers licensed, 2.6 million go-karts, and there was something else that was interesting there, probably. The main reason we're looking at cooperative and automated vehicles was really highlighted to me in that one particular slide. So that's fatalities graphed over between 1968 and 2014. You can see some particular initiatives that brought the fatalities down. But unless we do something, it will be quite some time before we reach our vision of 0 fatalities on the road. You can see there, obviously, that the ANCAP vehicle crash rating brought it down in somewhere between 1994 and 1996 drastically, and there's a few other measures that have brought it down, but yeah, as I said, it's going to be quite some time before we get to 0. That's not the summation of the impacts that road safety has in Queensland. That there is a chart that lists non-fatalities. So serious impacts, they're like a wave. A splash in the lake, you have a fatality. For each of those fatalities, you have a number of people that are impacted. For each serious impact that occurs, that same wave exists. So this problem is really large, actually, and it affects people on a daily basis, unfortunately. That slide there is all about the convergence of cooperative and automated vehicles. So in a moment I'll talk about what cooperative vehicles are and how they relate to automated vehicles, but there's a vision at some stage these two technologies will merge and we'll have cooperative and automated vehicles. So government's involved. We don't make cars, obviously. There's no Queensland government car, but we dictate the policies to support the vehicles that are on the road, legislation, regulations, licensing. We may be involved in certification. We are certainly for a number of other things. The federal government has a role to play as well. Where it says the arrangement for radio communications, that's not B105. That's reservation of the spectrum that allows the radios in these cars to talk to one another. Infrastructure, data and system integration, possible support of a security system. So that's my primary role in this project. There'll be an identity management system that someone has to run. We're not sure which level of government or if it's going to be government that's running it at all. There's a positioning solution. Cooperative automated vehicles won't work unless the cars know where they are. That's kind of obvious, I would have thought. And we're conducting pilots and studies. So at the moment, with regards to positioning, there is an SBAS solution that the federal government is running, for example. It's just a trial at the moment. And unfortunately, that trial, although it's running now and affecting our testing, won't be running when we actually conduct the pilot. So we're having to talk to the vendors about how to disable SBAS so that we get accurate results during our testing. National transport, so we're looking at this at a national level as well. SBAS is satellite-based augmentation system. It just allows the cars to correct for atmospheric conditions, etc. So when they're travelling along, GPS normally has a radius of about 10 metres accuracy, but with SBAS in theory you can get it down to 2 or 1, something like that. So the national, sorry, if I'm going too fast, can someone stop me? Because I'm not used to this. National Transport Technology Action Plan. So at the national level, they're looking at how it all fits together, where each of the jurisdictions would be involved, which jurisdiction should be doing which pilot, how Austroads is involved. So Austroads are doing road maps, operations, looking at how operations would work, registration and licensing to some extent. NTC is doing a really good role at the moment, which is fantastic to see. They're looking at the regulations and who would look after, who has access to what data and how the privacy parts of it would work. The Department of Infrastructure and Regional Development are the main federal body that I'm having to deal with. They're a lovely group of people. They're doing some policies. They've got a statement of intent. They'll be the ones that do the regulations around it, working with the regulations. They'll have the final say, probably, maybe, on the security system and the positioning part of it. My understanding is they're the owner, or at least the lead president, if you like, of the Transport Infrastructure Standing Operations Committee. So they've got a big role to play as well in coordinating what Australia's doing around cooperative and automated vehicles. So there's 4 parts to our little initiative. When I say little initiative, it's more like a program of work rather than a project. So there's the pilot itself. There's the automated part of the pilot where we grab an automated vehicle and test it on our roads. There are these people that I'm not familiar with, called vulnerable road users. So that's a terminology that I've only just discovered. Sorry, cybersecurity expert. Vulnerable road users are pedestrians, bike riders, motorcyclists, anyone who's more likely to, when they get hit, take a lot of damage. And change management, that's change management for our organisation. So where would we get our funding from if nobody had licences anymore, for example? What changes do we have to make? So the objectives are to validate the impacts and benefits of this thing called cooperative and automated vehicles. Is it really worthwhile doing? We're going to demonstrate the technologies and make sure they actually work. We're going to grow our own readiness and make sure that that we're ready when they come, and they're coming quite soon. Actually, I was quite surprised. And we're going to encourage partnerships and build capacity, so vendor relationships, etc. They're our objectives. That's our schedule. We've already started. Where it says planning there, that can be quite detailed planning. It was originally high-level detail planning, not diving into it too much, but as it turns out, to do the high-level stuff, sometimes you have to dip down into the low-level stuff, so that's what we're doing at the moment. Around the start of 2018, there'll be a whole point where we assess whether the benefits are still, the business case is still valid for going ahead with the pilot. And we're running 500 participants out at Ipswich. That'll be a survey that we send out, and it'll be members of the public that we're putting devices into with their permission, of course. There'll be some sort of incentive scheme that the team has already come up with. It'll run for 9 months and take us through to 2020. So what's the European stance? So the Europeans are saying interoperability is a must. It's unacceptable that people would die on roads because their car does not speak to another car. So that's C roads over in Europe. Our pilot intends to use the emerging European standards. They're still under development, actually, which makes it quite difficult to build to. We have some day one safety use cases. So what's a safety use case? It might be, for example, road hazard warning that we're working on at the moment. So road hazard warning, as you may know, we've got the Queensland Traffic website. You may not know that. I didn't know that until I was forced to do a security evaluation against it, but that's fine. It lists all of the road closures, roadworks, flooding events, all of that sort of stuff for Queensland. So one of our use cases is looking at taking the information out of that and being able to present it in a manner that these devices that are going to be installed in cars can understand and consume. There'll be a little something like an iPad. It's not an iPad, but pretend it looks like an iPad in your car for our pilot anyway, and it'll pop up, road closed ahead, something like that. The range of these things is about a minimum of 300 metres, so you'll get plenty of time to slow down and stop before you go through a flooded intersection. Multiple vendors to test interoperability. So we're having multiple suppliers that have all, in theory, adhered to the European standards. Again, standards are being developed, so it's a little bit tricky sometimes to all adhere to the same standard. And we're testing to see whether they work together. We're using a hybrid communications model, so that means at the moment they're using something called DSRC, sometimes called ITSG5. It's 5.9 gigahertz radio spectrum, short range communications, as I said, minimum of 300 metres, but apparently up to a kilometre. To address, for an Australian context, we're looking at addressing a scenario where you may have cellular communications, but you're outside of the range of another vehicle, remote locations, rural locations, etc. So we still want to be able to communicate. There's a road flooded in your area, even if we've got no road infrastructure there. So that's why one of the reasons that we're looking at 3G, 4G as an alternative to the short-range communications. That's an example of a safety use case. The safety use cases that we're looking at, I should say. So emergency brake warning, that's where your driver ahead slams their brakes and it'll tell you someone's just slammed their brakes ahead. You may want to take notice of that. The advantage of cooperative over an automated vehicle, from what I'm seeing so far, is that a cooperative vehicle has further than line of sight. An automated vehicle relies on its sensors. Its sensors can only, if there's a car in front of you, it can't see beyond the car in front. If there's a bridge to your right, or you're in an underpass and you're at a blind corner, your automated vehicle is going to make the same decisions potentially that you might. But a cooperative vehicle can be told there's actually a car coming that way, don't go yet. So that's the good news. Stopped/slow vehicles. So that's quite obvious. If there's a slow vehicle ahead, it'll tell you. Red light violator warning, that'll tell you if you're about to run a red light based on the signal phasing of the lights. Apparently there's a scenario where you're turning right, for example, because we're left-hand drive, and it's sometimes difficult to see because of either lanes or whatever the case may be, whether a pedestrian is actually crossing the road at that intersection, and there's been some fatalities around that. So that's one of the use cases that we're looking to avoid. Hazard warning, alerts drivers to upcoming hazards such as debris on the road. Back of queue warning, so it'll tell you if you're about to come up to quite a large traffic jam. In-vehicle speed warning, that's quite obvious. It tells you the current speed that you're doing and whether you're going over the speed limit or not. Roadworks warning tells you that there's roadworks ahead. Although these things sound simple, by the way, it's not actually. That's what our platform looks like at the moment, the current architecture that we're building toward. So over on the, I don't know if you can read that very well. So over on the left-hand side is back-end systems, the Transport and Main Roads jurisdiction that we're looking to integrate. So there'll be about, that's a good idea, to my mobile phone. He's right himself. Over on the left-hand side of the back-end systems that we're looking to integrate, towards the middle there is, in IT land they call it an integration platform, or a ETL, I think it's called. So it just takes those messages, converts them to a format that the stations can understand, and spits them out to the stations over there. So RITS, VITS, this is terminology that that's common amongst this domain. So RITS is the roadside station, VITS is the vehicle station. Vehicles will talk to each other. Vehicles will also talk to the roadside station. So what the heck is a roadside station? That would be a station that you put at an intersection. It connects potentially directly to the traffic lights. It knows what the phasing is doing around the traffic lights, and will tell you though, and will enable those use cases, red light violator, those sorts of things. SCS is a security credential management system. It's a PKI. I don't know if I'm talking terms that people don't understand, please say something. It's a PKI-based security management system, PKI being public key infrastructure, so you will see PKI in your everyday usage of online banking. Your bank has a certificate on it that your client connects to and says things like, is this a legitimate certificate or not? If it's not, hopefully you get some sort of warning saying someone has forged the Commonwealth Bank certificate again, and you'll be presented with some sort of warning. Now, this system here puts a certificate, in theory, on every station. So when a station talks to another station, it signs the message and says, this actually came from me. The other station, when it receives it, goes, there's a signature on this, which is good because I'll only accept a message with a signature on it. And I'll just check that it's a valid certificate. It is, so I trust that station. I missed that bit. That's kind of the majority of our pilot, apart from the technical bit. There is a team that we are using to analyse all of this data that we're collecting and analyse the safety benefits, whether it had an impact on driver behaviour or not. There's no point putting a technical solution in place if it doesn't change anything. So that's really important for us. We have some challenges, as I've mentioned along the way: accurate positioning, short-range network access, long-range communication standards. There's no long-range communication standards, so cellular communications over this network hasn't been defined yet. We're struggling through that at the moment. Use case, algorithm specifications, security, infrastructure needs and testing. These are just some of the challenges that we're having at a business level. Societal benefit cost ratio seems to be high, but there's going to be slow penetration. Reliance on government to fund startup, potentially. Need business case for all actors to sustain it. Model emerging, certainty needed. Yeah, that's very true. So the business model, we're not quite sure how that's going to work yet. CITS business integration, so you guys can read that out easier than me. If you have any questions on that, please feel free to ask. Oh yeah. So, as I mentioned before, and quite surprisingly, this slide reminds me of a joke I read on, it was either Dilbert or one of those comics, and it said something like, oh my goodness, we have 20 standards for doing this thing. We need a standard that harmonises all of this, and the end result is 21 standards. So this basically outlines some of those issues. ITS standards, there is an international harmonisation group attempting to bring together the European and the American standards so that they, work together. That'd be great. We don't know how we're going to address backwards compatibility yet. We don't know how we're going to address compliance or certification. Should these devices be certified to a level before they're allowed to work in Australian vehicles? We're not sure. And what should be certified? Good question. Security background. Integration with antivirus, that's not right. Integration with automated vehicles, standardised data sets, agile practices in government, risk over committing. How do we adopt a minimal viable transformation? What does that look like? We're not really sure yet. Hopefully that's the last slide. No, it is. Great. Did anyone have any quick questions, or do we do that at the end? Oh, I'm sorry. On to Nancy's.
Thanks, Sue, for that great outline of the CAMI program. And I need to switch to presentations. I just wanted to go through this, and some of you may have already come across these levels of automation, and we're switching gears from cooperative, which is the system that Stuart was focusing his presentation on, to automation, to automated vehicles. Now this can assume that there is cooperative technology on board, or it may not have cooperative technology on board and it's a human, so it's not, the vehicle's not talking to anything else. But there is consensus, and that's articulated through the Society for Automotive Engineering, about what automation means, and we're at 0 and 1. And there are some vehicles with further capability. And as you can see, there's an articulation of where the system kicks in, where the driver has to come back in. I think there's a very similar kind of hierarchy built up in the rail industry for driverless trains, for example. And this is the basis on which people talk about levels of automation. Now, this is something we worked on, or worked with Ostros a little while ago, to try and understand when are these things coming, because there's a lot of market hype about this thing. and that's something we can't forget. There's a lot of vehicle manufacturers out there looking for a new target market and overselling certain things. Where is the technology really though? Surprise. And when is it really coming? And this is, I guess, where the consensus seems to be leading. So, you know, when you talk about automated, it's not necessarily level 5 automation. We already have adaptive cruise control. It's a level of automation. We've already got that in our vehicles. It's the less reliance on humans that when I guess the driving environment becomes tricky, because when you have a mixed mode. But I just want to, I guess, bring this up, and there's different contexts within which automation exists or will evolve as well. For example, truck platooning, where you have freight vehicles following one another to bring operational efficiencies in their transportation. Or it could be about automatic last mile sort of public transit, which is, I think, Transport for New South Wales is looking at exploring some of those systems or solutions. I know WA was, there was some people in Western Australia doing that with RSC. So there's different contexts. You can talk about automated vehicles in different contexts. But from I guess from a government perspective, and this is most of my client base, I guess, from DSB, is there's a lot of impacts in different spaces in which government, like Queensland Transport Main Roads, are interested in. What does it mean to their planning infrastructure, or the physical road infrastructure? You know, when there's an endeavour to plan the next bit of public infrastructure, that's usually a 40-year horizon. But if you look at the timeline, there's planning assumptions already being made about what the future is going to be looking like based on today's behaviour, which may not actually come to fruition at all. And so what are those decisions made on that, the investment on that? The design standards, pavement condition can be quite different in different regional to suburban to urban contexts. The consistency of that is important. If you're talking about track platooning, are bridge design standards going to allow that? I mean, are the loadings going to be different? Or we have 3 trucks going in quick succession as opposed to maybe not. Lane markings and delineation between the road and the road verge, that becomes important for an automated vehicle. The roadside signage, the design for human readability today, does it need to be machine readable in future? And because there are more and more LED type and variable messaging out there when it comes to variable speed limit signs or messaging, that's not machine readable. It's not designed for that. So does that mean now we've got a whole swathe of infrastructure changes coming up and to the public purse? Of course, the cost to deploy and maintain them to a different standard than what is required for human drivers. What else is the impact on road operations? What does it really do for road safety? And that's the space that TMR is exploring. Of course, others as well, but I mean, there's other impacts as well. But that's a key one. There's a great promise of road safety benefits, but are they going to be realised? Or is there going to be other unintended consequences? Even if there's a benefit realised in one area, is it going to cause traffic flow breakdown and then cause other traffic safety issues instead? What does it do to traffic efficiency if a vehicle is stopping every time a pedestrian wants to, or somebody wants to cross the road? Is that going to lead to traffic breakdown, and what are we solving then in terms of mobility? As I said, consistency of the urban environment versus the suburban environment versus national or regional. Are there going to be changes to permits and licensing schemes? These are things that need to be understood to enable acceptance of these technologies on our roads. What is the impact on organisation? That's something TMR is also exploring. One of the key components of the CAPI program. And the fact that this technology is evolving quite rapidly in so many different directions causes enormous problems for this type of organisation. and government departments can't change very quickly, it's just not going to happen, is a middle ground needed, is about building resiliency to change and being able to test that across different scenarios, future scenarios. Transport for New South Wales is doing, taking that approach. The Metrolinx in Canada are doing that as well. And that's the type of change they should be looking at. Also, new versus traditional engineering capabilities. A lot of those road agencies have a lot of, I guess, the traditional engineering disciplines, which is, or capability in those, which is civil and structural engineering, the civil design, but not necessarily systems. You find the systems engineers embedded in the ITB, the people who maintain the ICT infrastructure, but not in terms of not in terms of the roadside. It's a very, very specialised breed, and it's not necessarily, the organisations aren't capable. And in terms of the processes even that these organisations have embedded within their procedures, don't take into account of things like systems engineering. And you, as a systems engineering body, you know that systems, complex systems, especially ones with a strong social techno interface, requires a certain level of robustness to lead to what you want. And of course, the technical disciplines that go down with that, software engineering, telecommunications, integration. Also, new delivery frameworks. The CAVI program is adopting agile-like delivery approaches, which is new to the business and in itself causes complications. But there are benefits to be gained by doing that. We just need to be able to understand how to harness that. And so you could benefit the project. Then, of course, there's the societal impact, which is expected, largely expected. The productivity gains, which I think were mentioned in the previous roundtable session. The road safety benefits, improved mobility, access to mobility, and TMR have conducted some survey, an initial survey recently. I can't, unfortunately, give other results because they're not out for publication yet, but there's some interesting results in terms of what people expect and how confident people are to utilise these technologies, and what kind of, how it'll help them in the future. Now, what happens if these expectations are not met? Do we end up with this scenario? And I'm unashamedly copied the Gartner technology hype cycle image. So where are we on that? Depending on what we really know about where the technology is at current versus where a car salesman is talking about. So now I stole this image as well from Miranda because what I wanted to talk about really from a systems context is there are efforts, there's this somewhat of a structured top-down approach to try and deal with this problem in Australia. And it's not only us, the Europeans have similar structured bodies that are exploring this space. And at the top level, we've got the Transport Infrastructure Standing Operations Committee. And as you go down, I guess, I wouldn't say down, really, it's not necessarily hierarchy, but they each add something to it, and there's collaboration between these bodies. There is collaboration from the body of knowledge that they create, for example, the Australia's guidelines to the road agencies about what this space means, what these problems mean to the agencies, and what kind of things they need to think about. Jurisdictions, by running these pilots and trials. I guess the biggest change in terms of policy level thinking is that it's not about mandating something for Australia's future, it's about becoming informed, understanding what this means, and do that by trials, by studies, and so these agencies can be better informed in making, in offering up policy change or regulatory change or whatever that is to benefit society here in Australia. And towards that goal, I suppose there's quite a lot of work going on around Australia alone. As you can say, pretty much every state is doing something, in that, except for maybe Tasmania, but that may be by lack of information, knowledge about that. WA, they've got this. And it's not just about the trials, it's also about the creation of test beds that allow multiple organisations to come and play with their toys, play with their rules, play with their procedures, whatever that is. And one of the newest ones has been set up in Victoria, the Australian Integrated Multimodal Ecosystem, which is actually spearheaded by the University of Melbourne, I think. And you've got people like Coda Wireless involved, you've got people like who makes switches? Cisco, yeah. So Telstra, because all these players and the actors have a part to play in this ecosystem. It's about creating that arena for people to come and test this new problem, I guess. Where am I? Okay. Internationally, these are the ones I'm aware of through WSP, which is where I work from. The Ann Arbor Connected Vehicle, I think some of you may have heard about that at INCO-CIS earlier this year, as well as the Columbus, Ohio Smart Cities Challenge. Some of these are about bigger than the particular CAV space that we're looking at. This is about smart cities, mobility, dealing with mobility as opposed to the transportation in a vehicle. That's, I kind of almost think of it as like layers in an onion. You've got society and how it works, and then transportation is part of that. And whether your transport problem is a big problem or a small problem, regardless, that's the context in which you are operating as a systems engineer. Of course, the international ones, you've got other, Europe, for example, you've got multinational jurisdictions to work across. And most of, I wanted to point out something about why I think we've selected the European standards for the CAV program, because one of the things we discovered through the Austroads study is that most of our vehicles that come here, they're actually built for the European market. So it makes kind of, you select a standard to try and follow, because we are not an influencer in the type of vehicles that come here, or rather in the standards of vehicles. We buy what we get, or we have to deal with what we get. So, and the European standards was something that was seen to be a significant influencer for us. What else? So, and I also want to point out that from a, I guess, systems perspective, there is cross-border collaboration of a sort. It's not formal, it's not too structured as such, but there are ITS forums. ITS, by the way, for those who don't understand, is intelligent transportation systems, and this the cooperative ITS, automated vehicles space, big data, mobility, all that fits within that ITS space. You've got the ITS World Congress. It happened in Melbourne last year. There were about in excess of something like 11,000 people turned up, I think, including the public, who were very interested in it. It was opened up to the public as well. The ITS European Congress, ITS Australia Summit. The World Congress is actually happening right now, in fact today in Canada, isn't it? Yeah. So that's the place to go to actually exchange your ideas or your knowledge in this space and capabilities. Then there's knowledge sharing, or there's pilot programs and other types of vendor standards development, for example, the C-Roads platform, that are occurring across the world. And there is some sort of knowledge sharing, or there's information available on their websites, the published documentation, and the CAVI program takes advantage of these and tries to keep in sync, see what we can learn off those who've gone before in certain spaces, and others because we absolutely just need to understand what the emergent standard is, for example. So there is, as I said, not formalized, but there is some collaboration occurring in this space, which is promising, which is nice to see, I guess, from a systems engineering point of view. I put this up, I'm not sure why. I think it's because I had to get approval internally, and some of my audience not necessarily is aware of what systems engineering is. But I also thought I'll put this up because even in this one forum, because the international standard ISO 15288 shows a very structured breakdown of the processes involved and the process areas involved that need to work in sync, the technical project agreement enterprise. Now, all of this really still assumes that there is a single entity that can actually control these, can influence these processes. In It's not necessarily true in this domain. There is at a project level, but again, there's so many influencing factors that come into play that it's not your normal bounded system. But these features still are required, or these skill sets are still required. So it is kind of business as usual for a systems engineer to have the technical depth in one or more of those areas, to understand the technical management processes required to actually produce what you want to try to achieve, whether it's a trial system or an automated vehicle. And that aligning of the technical, the project, the agreements, and the organisation that has to occur doesn't change anything about the use of systems engineering principles in this kind of problem space. But what is different from if you take the CAV domain or challenges at a domain level, you have those types of features or characteristics. It's multiple types of organizations and no one leader. You've got the public interests, you've got your private interests with commercial agendas, you've got your regulatory bodies that tend to be very late or more reactive rather than preemptive in creating these the regulations or changing laws. Your industry groups, like Stuart mentioned, the service industry, they are definitely sure that their industry is going to be broken in half, if not smashed to smithereens. So they're already aware that maybe the mechanical, automotive, service industries, the jobs that are here today won't exist tomorrow. But they're also looking at it from the point of view of, well, there may be other jobs available instead. But it's about really giving reassurance to those groups, or finding those groups need to find their path into the future with this evolution that's occurring. Then balancing commercial drivers versus the public interest, which is what agencies like Transport Main Roads striving for too. And Stuart mentioned they're using the 5.9 gigahertz spectrum, but there's not necessarily agreement everywhere about that is set in stone, because I haven't delved into this in too much depth yet, but I understand there is, it's also a very lucrative area of the spectrum for the telcos to use. So there is a bit of a, let's say, discussion ongoing as to who can mandate, or whether it's mandated as to which bits of the spectrum is going to be used for safety critical operations. Then you've got your societal influences. Your culture can have a huge influence. Somebody mentioned in the roundtable just before that, well, when you have automated vehicles where, the base rule is that the vehicle will stop if there's a pedestrian or somebody's across the road. Well, why? I mean, what has changed that someone now no longer uses a pedestrian crossing, thinks that they can just cross the road because it's going to be safe, because that's going to increase the problem in terms of traffic flow. But you go to another culture where people don't think that way, people will still follow the rules, you won't have that problem. And those expectations I went through before about the mobility expectations, the safety or the efficiency gains, productivity gains. There's a demand as well as a turn off if things don't come fast enough, or there's an accident like that, the guy who didn't mind what he was doing in his Tesla vehicle and crashed into something and died, so that's an expectation that dude had about what he could do in his vehicle, and ignore the fact that he needed to keep his hands on the wheel. And those societal influences will work across jurisdictional boundaries, which will be very different. And how do you then expect a vehicle that's been designed in, I don't know, wherever, Spain, and the technology on board is, it's designed by half a dozen other technology providers, and you've integrated this thing which hopefully operates as the standard talks, but then in jurisdiction A versus B, it's expected to behave a bit differently again. So how do you work through those problems? There's also multiple knowledge domains needed. You're bringing technology, you're bringing legal insurance industry, you bring in human factors, people who understand society and the human individual, who understands AI, there's communications. There's just not, it's not only in the technical domain that this problem exists or requires capability. The other thing that's really deadly about this particular domain challenge is that it evolves so rapidly. And the organisation's ability to deal with that rapidly changing environment is one of the biggest problems I think this domain faces. And then of course the technical challenges which Stuart ran through. So from an INCOSI transportation working group perspective, I was thinking about this and it's like, what do we do as systems engineers? Yes, there's we can see a technical challenge as the project might present. We can help on that. But how do we deal with these issues? Can we deal with these issues? Do we have anything to contribute? And this is where this is where the systems of systems challenge is for systems engineers to, I think, understand what this domain presents as problems, understand and get on board with the level of technical maturity that exists, so we can understand where those problems, where the real gaps are, and can we contribute to those. Maybe we need to create new paradigms for systems engineers specific to this domain. Do we develop a body of knowledge? Do we have time to do that? Do we need to be clear on what kind of skills we need to evolve as systems engineers to help this domain? What lessons can we bring from other domains, and how do we transfer those lessons? Because it won't be one-to-one. And what are those non-technical skill sets and other characteristics or parameters, I suppose, we want to bring into this? Understanding those industry drivers, and business enterprise knowledge is something key here because of the governmental shift that needs to occur. And that's a systems challenge in itself. It's a business systems challenge, but it's an important one to deal with. I think that about concludes what I wanted to say. And I'm hoping that enough interest exists within the systems engineering community and specifically the Transport Working Group to look at these types of things we need to work on maybe in the next couple of years, and we have to work fast if we want to really be relevant in this space. Thank you. Any questions? And Stuart, myself.
So, thanks very much, Waratah and Stuart. I think you've undersold your ability to